Hello and welcome to another Mr. Marriott Maths video. This time we're attempting question 5 of the October 2021 Edexcel Decision Maths paper. In question A, we're given a list of 10 numbers to be sorted into descending order, really important information. And we're asked to use a quick sort to obtain the sorted list. And you should show the result of each pass and identify the pivots correctly. So I'm going to rewrite the numbers 30, 12, 5, 2, 23, 18, 36, 10, 15, and 24. And we're told that there's 10 numbers, which means that the middle is going to be between numbers 5 and 6. And the convention for Edexcel is to use the middle right value. So in this case, it's going to be 18, the pivot. I'm going to circle 18 as my pivot. I'm going to go through my list, and any number that's greater than 18, I'm going to write to the left of it. So I've got 30, my next number is 23, then 36, and 24. Then I'm going to write the number 18, and I'm going to put it in a square box to say that it has been a pivot and it's now in a fixed position. I'm going to go through my list again and write all the numbers from left to right that are smaller than 18. I'm going to get 12, 5, 2, 10, and 15. I'm now going to sort the sublists. I've got a sublist with size 4, so the middle right item is 36. And I've got a sublist of 5, so the middle item is 2. So now what numbers are larger than 36 in this sublist? And there isn't any, so 36 is going to go right at the start. And 36 is now fixed into place. I've then got 30, 23, and 24. I've then got 18, which I know is in that fixed position. I'm going to do the same thing to the next sublist. What numbers are larger than 2? And all of the numbers are larger than 2 in this sublist. So we're going to get 12, 5, 10, 15, and finally 2 in a box to say that 2 is in a fixed position. I'm now going to apply this process again. I've got a sublist of 3, so the middle item is 23, and I've got a sublist of size 4, so the middle right item is 10. So I'm going to have 36 fixed into position. Both 30 and 24 are larger than 23. Now I'm going to have 18 in its fixed position. And I want the numbers larger than 10 to go to the left of it. So I'm going to get 12 and 15. I'm going to fix 10 into position. And then I'm going to have 5 and then 2 in a fixed position. Now I'm going to consider all of the sublists that have size greater than 1. So 5 I could use as a pivot, but it's just going to end up where it is. So I'm going to consider all the sublists of size greater than 1. I'm going to get pivots 24 and 15. So now when I try this again, I'm going to get 36 in a fixed position. 30 ends up to the left of 24, which is now in a fixed position. 23 is fixed. 18 is fixed. And then I've got this sublist here. And 12 is smaller than 15, so 12 is going to go to the right of 15. So I'm going to get 15 in a fixed position. Then 12. 10 is fixed into position. I've got 5. And finally 2 is fixed into position. I've now only got sublists of size 1 that haven't had pivots applied to them, which means that they will end up in those fixed positions. So therefore, the sort is complete. So what are the 4 marks awarded for? Well, the first method mark is for using a quick sort. So if you're choosing pivots and then sorting based upon that pivot, you get 1 method mark. You get an accuracy mark for performing the first pass correctly and choosing the next pivots of 36 and 2. And it must be mentioned now, if you're only selecting one pivot per pass, i.e. only doing one sublist at a time, you won't get any accuracy marks. Get another accuracy mark for conducting the second and third passes correctly. So for getting to this stage and not having to select a pivot by now, then you get a final accuracy mark for doing the correct solution. So for getting to this stage correctly. And you need a sorted complete statement. If you don't have this statement, you don't get the accuracy mark at the end. Okay, moving on. And we're told that the 10 numbers are to be packed into bins of size n, where n is a positive integer. And when the first fit bin packing algorithm is applied to the original list, the following allocation is obtained. And we're asked to explain why the value of the integer n must be either 44 or 45. And to do this, we're essentially going to apply the first fit bin packing algorithm in our heads and think about why numbers weren't placed in a particular bin or why they were placed in a particular bin. So let's start off applying the algorithm. In the first bin, we're putting in 30 and then 12, but we're not putting in 5. So 5 wasn't placed into bin 1. So 5 into bin 2 implies that the size must be less than 30 plus 12 plus 5, which is equal to 47. But it also means that the size must be at least 30 plus 12, which is equal to 42. So we currently have that n is at least equal to 42, but it's definitely smaller than 47. But then we see that 2 has been placed into bin 1. So 2 into bin 1 implies that the size must be at least 30 plus 12 plus 2, which is equal to 44. So we've got it down to 44 is smaller than or equal to n, is smaller than 47. Okay, carrying on. We've placed 5 into bin 2, we've placed 23 into bin 2, so bin 2 now has a size of 28, but 18 has not been placed into bin 2. So 18 into bin 3 implies that the size must be less than 5 plus 23 plus the 18. We rejected 18 for bin 2, so 18 doesn't fit into bin 2, so the size must be less than this sum, and this sum is 46. So we've now got to 44 is less than or equal to n, is less than 46. We're going to carry on thinking about how the numbers are placed, but now the numbers are sporadic enough that we can't really determine whether n was 44 or 45. But we know that n is either 44 or 45, which is all the question was asking. So, mark-wise, was an independent accuracy mark for stating this here, that n is between 42 inclusive and 47 exclusive. Another accuracy mark for determining that n must be at least 44. And then a final accuracy mark for determining that n is less than 46. And then question C, we're asked to use a first fit decreasing bin packing algorithm determine how the numbers can be packed into bins of size 45. So because we're using first fit decreasing bin packing algorithm, I need my sorted list, so I'm going to keep that at the top. And I'm going to get bin 1. And inside bin 1 goes 36. If I add 30 to this, it's going to have a total size of 66, which is too high. So 30 is going to go into bin 2. 24 also needs to go into its own bin. So bin 3, 24. And if I put 23 into this bin, it's still going to be greater than 45. So 23 needs to go into its own bin as well. Next up, 18. If I consider putting 18 in bin 1, it's too big. Bin 2, it's too big. But I can put 18 into bin 3 to get a total size of 42. So 18 can go into bin 3. Next up, 15. 15 can't go into bin 1, but it can go into bin 2. Next up, 12. 12 can't go into bin 1, can't go into bin 2, can't go into bin 3, but it can go into bin 4. Next up, 10. Can't go into bin 1, can't go into bin 2, can't go into bin 3, but it can go into bin 4. Next up, 5. 5 can go into bin 1. And finally, 2 can go into bin 1. So I've got this bin packing algorithm here, and I've got these 4 bins. So how would the marks have been awarded? Well, for getting all of the values in these boxes right here. So for placing the first 5 values correctly, you'd have got a method mark. For placing the next 3 values correctly, you'd have got an accuracy mark. Then for placing the final 2 values correctly, you'd have got a final accuracy mark. So that does mean that we've reached the end of the question. So until next time, thank you and goodbye.